Great. So you're given two intersecting line. Right. Point A. Oh. Okay. So this the intersect at A. They give you the intersection point here. A. You know you can actually check whether it's in L2. So you can just sub into here, this Cartesian here. Alright. It satisfies this Cartesian equation. When you sub x equals to -1, y equals to -2, and z equals to 1. Okay. So this is line 2. So if line 1, you just check, it's just very quick check, you can actually check. Just know how to use the line equation. That's about it. I think vector line equation for line 1 is quite fast. Line 2 is given. (0,15) OB minus OA minus 1 1 3 4. Okay, so this will be L1 (0,15). I'm going to just use OB. Lambda 134. Go. L2. X minus 1. This will give us mu. So 3 plus mu. One to 3 plus mu 1 to 1. Should be quite fast. The first one is quite easy lah. Second one is angle between L1 and L2. Angle between L1 and L2 is just between two lines. D1 dot D2. Just use cosine rule. That's about it. Yeah, that's about it. So cosine theta goes to 134 dot with 1 to 1, and then square 1 square plus 3 square plus 4 square, 1 square plus 2 square plus 1 square, plus 6 plus 4. Calculator. 26. 6. 28. Yeah, pretty okay, I think. Pretty standard. Part 3 is just a relationship between a point and a line. So B to L2, B is on L1. Yeah, but we may need to use it for part 4, but we just do B. Just draw a line. This is B. B will be 0,15. There you go. Okay. You want to find the full perpendicular to this line here. L2. Okay. L2 has got point A. Is that point A? No, that's not point A. I'm just gonna use 1, 2, 1. L2. Point A is on L2. You can use point A. You can just use this point now. 1, 2, 1, 2, 3. Direction here is 1, 2, 1. Okay. So remember, what we need to find is finding what is the housing address mu. Every point has a mu, corresponds to F. So I'm gonna just do is for some mu belongs to a certain real value, I know OF will just satisfy the line equation. 1, 2, 3 plus mu 1, 2, 1. So what I'm gonna do is actually just, and then I'm gonna use this 90 degrees here. So I know BF and D2, they are perpendicular. So BF with D2 equals to 0. BF would be OF. OF minus OB. D2 will be 1, 2, 1 equals to 0. So just dot them. Zero. Huh? Hmm. 0, 1 minus 0, 2 minus 1, 1 minus 2, 1 plus 2 minus 2. This is so OF sub back the line equation 1 to 1. There you go. 1 minus 1 over 6. 2 minus 2 over 6. 3 minus 1 over 6. So we can just factorize the 1 over 6 out. That's it. So for the last part, right, you have to find L3, which is the mirror image of L1 and L2. Here it makes sense. Label everything which relates to L1 and L2. Okay, I will try. So for a starter, we know that L1 and L2 intersect at point A. We are given that it intersect at point A, right? So let's say this is L1 and L2. L1 has got B, is it? B, which is actually 0, 1, 5 here. Okay. Then you are told to find the mirror image of the line. So the mirror image of a line should be here, right? So if this is the mirror, say this is a mirror here, what you would expect is that the mirror image of this line here yes, it is. It's here, right? Like basically, this would be your mirror image. The angle here will be the same angle here. Okay, is that right? Okay. Now, and very often, what you will need to do is essentially you know that this B, when it looks in the mirror, the B prime will be here. Am I right? So in other words, you draw this down, it will be here lah. This is the foot of perpendicular here, which is what we found just now. B to line L2, which is F. So this part here is F. Okay, so it backs to what I've mentioned before, which is what I asked you to highlight before. Anything to do with mirror image, you need to use ratio theorem, midpoint. Okay, so I repeat, you have to find, now the thing is, because we already have A, which is where they intersect. A is -1, -2, -1, -2, 1, right? -1, -2, 1. B is actually what's B? B is actually 0, 1, 5. Okay, then F here is actually 1, 6, 5, 10, 7. Very ugly number, but okay. 1, 6, 5, 10, 17. Okay, so the question now is, what is my B prime? That's the thing now. So you know that this mirror image here, as B looks into the mirror of L2, this will be B prime. Once I get this, I have 2 points, I can form the line equation L3. I think, yeah. Yes, so when you use mirror image, don't go and use AB, AF, and OB prime. Yeah, don't do that, because it's going to be you need to find AF and so on, right? Don't do that. So typically what I'll say is just take an origin, then you just stretch it out here, then you use midpoint theorem based on O instead of basing it on A. Okay, because O is much better. So in this case here, by midpoint theorem, okay, we know that OF is OB prime plus OB over 2. Right, so you take this middle one, then you just the side add up together. Actually it's just ratio theorem. You take the side, cross multiply the ratio here, and you just add the ratio up. So yes, so I'll prefer you to use O as well, because it's easier. Then you don't need to go and find, yeah. So this case here, 0, 1, 5. So OB prime is 2OF minus OB. This will just be 3, because it's a 6, right? 1/3. 1/3. 5, 10, 17. Minus of OB, which is actually 0, 1, 5. Okay, there you go. 5/3. So this is my OB prime. I can actually find a line L3 already. Okay, I'll just find line L3 by using 2 points lah. So L3, the line L3, we need to find the direction AB prime first. Is 1/3. 5, 7, 10 over 2 minus OB prime minus OA, which is -1, -2, 1. Okay, that's about it. 5/3 plus 1, 8/3. 7/3 plus 2, 13/3. 2/3 minus 1, -1/3. Okay. Direction vector, very annoying. The 3 there. So multiply by 3 throughout. 830 minus 1. So this is the direction of, so line 3 will just be, you just put A, which is minus 1 minus 2, 1, plus alpha. Yeah. Okay, so that's how you do the last part which is part 4.